So when you go to ChatGPT and when you try to give some prompt, what ChatGPT does is ChatGPT understands that prompt and also keeps the history of those prompts, so that whenever you ask the next question, it can understand that what the question is and it has the context to it, and it will give you the response according to that context. You do not have to give the context again and again. Let's see how we can build that system with Spring AI using the OpenAI ChatGPT APIs. So what we are going to do is, if I give you that same example, what I was talking about is, if we can go to chatgpt.com, and here you can see that this is a ChatGPT. So what I will try to tell is that my name is Shabir. So here you can see that I have just given the prompt that my name is Shabir, and you can see that it has updated this memory. You can see that the memory is updated and it says that, got it Shabir, how can I assist you today? So now whatever the name that I have provided, that my name is Shabir, that information is been stored as a memory information for this client. ChatGPT is a layer, it's an application on top of the LLM model. Okay, so LLM model does not know directly about me, but there is a history with ChatGPT that knows that, okay, there is a Shabir who has given this context. So now if I ask again, who am I, or what is my name, then you can see that your name is Shabir. So it has the context that whatever I have given earlier, and based on that information it is giving me the data back. So I do not have to ask again, or I do not have to give the feed again and again. It knows the context, it will save the context, and whenever I want to use it, I can use those contexts and build the data on top of it whenever I want to do. Okay, so that's what we are going to build today using the OpenAI's API. So what we will do is, we'll create a Spring Boot application, and with that Spring Boot application we will build this API where it knows the context, or it will handle the context for us. Hey, what's up everyone, my name is Shabir and you are watching Daily Code Buffer. Here in this channel we build a lot of different applications, lot of different topics, and understand and simplify the tech for each one of you. So if you are new here and interested in those such topics, then subscribe to my channel for upcoming videos. So what we will do is, let me just create a Spring Boot application here. So to create a Spring Boot application, we'll go to start.spring.io. Okay, and I will create a Spring Boot application here where I have selected the language as Java, the project as Maven, the Spring Boot version as 3.3.5, and let me just give the group as Daily Code Buffer. The artifact I'm gonna give is AI chat history. Okay, the name is same. Let me just give the package as just AI. Packaging I'm gonna give as jar file. Java version is 21, and I'm gonna create a web application, so I'm gonna add Spring Web, and also I want to add the Spring AI dependency. So let me just add OpenAI. Okay, you can see that this is Spring AI support for ChatGPT, the language model, and DALI, the image generation model from API. So this is what I'm going to add as a dependency. We have added the similar kind of dependency in the earlier videos as well. So we have created multiple videos to go through the Spring AI, and in everything we are adding the same dependency. We are gonna add the same thing. Let's generate the project and open an IntelliJ IDEA. You can use your choice of editor. Hey, let's talk about something we deal with every day, that is passwords. How many of them remember to struggle them, or even worse, try to use the same password across multiple systems, and one of your password is hacked? Your game is over. That's where NordPass comes in, created by the minds behind the NordVPN, world's most popular VPN service. NordPass is an easy to use password manager designed to keep your personal and business accounts secure, safe, and stress-free. With NordPass, you can secure and store your passwords, credit card information, and even get an alert if your data is breached on dark web. You can safely share your credentials for autofill across your team members without any hassle with just one click. It uses end-to-end encryption and zero knowledge architecture, so no one will be able to see your password, not even NordPass themselves. It's super simple and works across all your devices. It's fast, simple, secure, and stress-free. So ready to take control of your passwords? Use code DailyCode at nordpass.com/dailycode to get a 3 months of NordPass business. Trust me, once you use it, there is no going back to your sticky notes and emailing your passwords. So stay secure and stay stress-free with NordPass. Go to nordpass.com/dailycode. Now back to the video. So I have opened the project in IntelliJ IDEA. You can see there's AI chat history. What I'm going to do is, I have to add few configurations to connect my application to the OpenAI. So I need to add the API key, the organization ID and everything. So let me just add those information here. So these are the fields are needed. So it is Spring AI OpenAI API key, organization ID, project ID, and the model I'm going to use. Okay. And for everything, you can see that I've added as the environment variable. So everything I'm going to use using the environment variable. So I'm not sharing those information with you, and you should also not share those information with anyone. You should add in environment variable, and you should not be committing those to your Git as well. So that's what we are going to do. And what we will do is we'll set each and everything in the environment variable as well when we start the application. So once we have done it, let me just go through the Java package AI chat history application. Let's start the application. It should fail because I have not set any environment variable. Okay, so let me just go here, edit configuration, and within this environment variable, let's add everything. So I have added this information, OpenAI key and everything. Let me just apply. Okay, start the application, and it should work. Okay, the application started. Now what I have to do is I will just create a simple API. Okay, so let me just create a chat controller here. So this is what we have built earlier as well, that I'm going to create a REST controller, and I'm going to create the reference of a chat client which I'm going to use. So private final chat client, and let me inject using the constructor injection, and I'm going to use builder here. Let me convert this to builder, and it should be builder dot build. Okay, and now let me just create one controller. So I'm going to create public string chat, and this is going to be your get API get mapping, and let me just take a request param as an input. So it's a request param which is a string, and the variable is q. And what I'm going to return is return chat client dot prompt dot user message as whatever the query is, whatever the prompt is, dot call the API and get the content back. Okay, you can see that it's a simple API that we have built. This is what we have been building in a lot of different applications, a lot of previous videos as well. Okay, so now let's start the application and let's hit this API. And now you can see that the API, your application started. So I'll go to the browser, and what I will do is I'll go to localhost and q equals to, I'll just say my name is Shabir. Okay, and you can see that it got me the message that nice to meet you, Shabir, how can I assist you today? So you can see that I have queried one API, queried one prompt, and I got the data. Now let me just prompt it again. I'll just ask what is my name, and you can see that I'm getting response that I'm sorry, but I cannot determine your name based on the information provided. That means that whatever the prompt that we did earlier, that information is not available with the LLM model, right? And based on our client, based on our API as well, we have not sent such information so that your LLM model can understand that what was the context or what was the history for that prompt. Okay, now we have to build that similar to what we saw here in the ChatGPT. So for that, what we have to do is we have to use the advisors. Okay, so let's understand what are advisors. So if you go to the documentation of Spring AI, you can see that you have the different advisors API. Okay, so if you go to this advisors API, okay, and you will be able to understand that what is an advisor. So that means whatever the ChatGPT or whatever the prompt that we are doing, whatever the API call that we are doing to ChatGPT, for that we are giving an advice, so that based on that advice some extra task will be performed on it. Okay, so if I show you here, so what happens is I have a prompt, okay, and this prompt is taken from your API. Okay, so this is the API that we have built, that is the chat API, right? So your prompt is provided to your API, that is your chat API, and from this chat API you call the LLM model, that is your OpenAI model, and you get the information back. Okay, and that's what you return back to the client as well. Now you can see that there is nothing in between. Whatever you query, that query has been provided to your LLM model, and once you get the data back from the LLM model, that's what the response is. Now when you add the advisors, what happens is, whenever you do prompt, okay, what will happen is there is an advisor in between. This is an advisor. So for your prompt, what will happen is it will create the advised request and it will return as an advised response. Okay, so the moment you call the prompt, whatever the prompt is, it will have the advice request created for your prompt. That advice request will be passed for your LLM model, and whatever the response back you get, that has been converted to your advice response, and from that you will get the response back. Okay, so here you can see that there is an entire mechanism added to handle your advice request and advice response. Okay, now here I need to handle our context. I need to handle the history. Okay, so what happens is Spring AI has provided the advisor that's called the message chat memory advisor. Okay, so that means that it will handle the chat memory for us. Okay, so what it will do is, whatever or whenever we will do any request, for that whatever the user messages we added, right? So that is the message that we send to the LLM model. That is a user message and a system message. And whatever the response that we get, that's the assistant message. Okay, there are 3 types of roles available. So these 2 are the data that we send, and this is what we get as a response, as a rollback. Okay, so what message chat memory will do is, it will handle the data as a memory. So whenever I will do the request, what it will do is, it will create a map, and in that map it will store the prompts based on the conversation ID. So based on the conversation ID, it will store the list of messages, and whatever the data that it got back, that also will be stored in this particular map. And whenever we do the request again, what it will do is, it will take all the data from this conversation ID, from this map, and alongside the new prompt that we have added, it will send the older prompts as well. So now, rather than just one prompt, whenever I'm doing the request again, it will have the entire list of prompt which was previously done, and now we are sending everything back again. So now you can see that it will have the constant history available for your LLM model to understand, okay, these are the prompts been done, this was the first prompt, this was the response back, because based on the role you will understand, right, that whenever we are doing the request, it will be user role. Whenever I'm getting the response back, it will be assistant role. So now your model will understand that, okay, what was the request, what was the response, and based on that entire history, whatever the new prompt is there, it will give the response based on that data. And this is one of the advisors available. The other advisor is prompt chat memory advisor. So it's a message chat memory advisor and prompt chat memory advisor. So 2 advisors are available. So we can see those 2 advisors in action as well. But this is how it will store the data. And if you want to have your own advisor as well, then you can just implement the advisor interface, and we can have this entire implementation based on your models or based on your LLM models as well. These are the default advisors available implementation in Spring AI, and whenever or whatever we need extra information or custom implementation, we can do as it is based on the advisor interface. Okay, so it's really easy. What we have to do is, as we talked about the advisors, we have to implement the advisor. So let's go to the IntelliJ IDEA, and what we will do is, we will implement this chat advisor. So here you can see that this is the builder that we are creating, and what we will do is, we will add the default advisor. Okay, and this default advisor, if you go, you can see that this default advisor takes the advisor. Now if you go to this advisor, this is the interface. Okay, here you can see that it has the order of precedence, like if we have multiple advisors, which advisor should be on priority to be executed. Okay, so for that we have to add the precedence and what is the name of the advisor. Now if we go to the implementation, you can see that there are different types of advisors available. In the previous RAG implementation, we have already talked about the question answer advisor. Okay, now let's talk about this simple message chat memory advisor. So if you go to this advisor, you can see that it's the class which is implementing the abstract chat memory advisor, and it has the constructor message chat memory advisor which is taking the chat memory. So that means it is handling the chat memory. And if you go to this chat memory, what it is doing is it is a interface and it is just a conversation ID and a message. That's the map it is going to create. Okay, so it's going to take the conversation ID, and for that conversation ID, what are the different messages available, and these messages can be of user message or assistant message, because it will be based on the conversation for us. So whenever we are going to use it, we're going to pass the chat memory as well. And if you go here, how it's going to implement is based on the chain. So this is the method. If you see, right, that is your advice request. Okay, it is taking the advice request as the input, which we talked about here. Advice request and advice response. So it's going to take the advice request and it's going to return the advice response. And what it does in between is before processing and after processing. Okay, so if you go here, before processing, what it does is you can see that it's taking the request, it is getting the conversation ID, it is retrieving the size of your chat memory, getting all the memory messages, okay, from your chat memory store. And then you can see that it's creating the list of messages, and that list of messages is passed as a user message here in your prompt. Okay, and that's your advice request. Same way, once this is done, this advice request is passed into the chain so that next sets of action can be performed. If there is a list of different advisors, next advisor can work on it. And once this is done, you will get the advice response in back. And once you get the advice response back, the same thing happens. You have to work on that advice response, take the assistant messages and add to your chat memory. Okay, that's what it is doing. So you can go through this class. It's a really easy implementation for this, and if you want a custom implementation, we can do that as well. So for the implementation, what we have to do is we can just go to a chat controller. We have defined that we need an advisor, and we also check that we can have the message chat memory advisor. So let's implement that. I need new message chat memory advisor. Okay, and this message chat memory advisor, you can see that there are different constructors and it needs the chat memory. So I can go to chat memory. So let me go to chat memory, and this is the interface. So for this interface, you can see there is a in-memory chat memory implementation by default available. If you want to have this in-memory chat memory implementation, like you want to store something in a database as well, we can do that as well. It's a custom implementation, but currently it is storing everything in memory, so we can use this as well. So let me just use this as an in-memory chat memory. So I can pass new in-memory chat memory implementation. So now you can see that I have added a default advisor. That advisor is of what? Message chat memory advisor. That means it's gonna handle my memory for my chat messages, and where it's gonna store, it's gonna store it in memory. Okay, that's it. Your implementation is done. You do not have to worry about anything else. Internally, you have seen that it is gonna handle our conversation IDs, and based on that conversation IDs, it's gonna handle our entire list of messages for us as well. And if you want to bypass those information, if you want to pass it explicitly by here in the user specs, you can pass those as well. In the advisors, you can pass those as well. Okay, you can build around here as well. Let's just restart the application. Let's see how it works. Okay, so here you can see that I have restarted my application, and if I go back to browser, and if I go here, and I can just say that my name is Shabir. Okay, and here you can see that it has given me the response that hello Shabir, how can I assist you? Now let me just ask that what is my name. Now once I do this request, it already has that response handy, right, as a conversation. That the first prompt was my name is Shabir, okay, and the response was hello Shabir, how can I assist you? So that I have those two contexts available. Now if I ask based on top of that context, I should get the information back that okay, your name is Shabir, how can I help you further? And this will be available throughout your different clients as well. You can see that if I'm going to different client, you can see that I'm getting the same information again because all your data is stored against a conversation. Okay, now if I check for the other implementation, that was the prompt, right? So if I go to prompt implementation, so let's go to the advisor back again. This is the advisor, and if we go back to the prompt chat memory advisor, so what it will do is it will add your conversation history in the memory part of your prompt. So earlier what it was doing is it was everything adding as a list of messages, as a role messages. Okay, now prompt chat memory will do everything based on the prompt. So it will add everything in the prompt because all the different LLM models cannot handle list of messages. OpenAI's LLM model handles the list of messages so that we can implement it. But if you are using any other LLM model, if they are not supporting list of user messages, then we have to use the prompt chat memory advisor, where we are passing all those information, all those context in the memory, in the prompt section as it is. Okay, so if we implement this, you will get this similar result as well. So if I go to chat controller, what I will do is I will just comment this out and I will just add another default advisor, and here it will be prompt chat memory advisor, and this also expects the chat memory. You can have your custom implementation, but here we can use in memory as well. So it's an in memory chat memory. So now you can see that your entire implementation is done. So if I restart this application, this should work as it is. So the application is started, and if I go back to the browser and if I say that my name is Shabir, okay, you can see that nice to meet you Shabir, how can I assist you today? And if I go back and I ask what is my name, it should say that your name is Shabir. So you can see that this is also handling the context for you. So we saw two implementation, that is message chat memory advisor and prompt chat memory advisor. Both have the different implementation because of the different behaviors of the LLM model. If you know that your LLM model can handle the list of user messages based on the role, you can use memory chat memory advisor. If not, by default you can use prompt chat memory advisor. So this is how you can build the APIs similar to what ChatGPT is handling their API on top of the LLM models, so that all those conversation history we can maintain and we can get, or we can build our outputs on top of the previous prompts that we have provided. So this is how you should implement. I would encourage you to go through this API and the implementation of the different classes of the advisor interface that we have gone through, and try to build your own AI or try to build your own APIs which can handle the conversation history. You can also add the different modifications, like you can have the implementation of the chat memory as well as a default, as a custom one. So you can also do your chat memory stored in the MongoDB or in Kafka or in MySQL as well. All those different things we can do as a custom implementation. Okay, so just try it out, and if you have any doubts or any queries regarding any of the things that we have covered, then do let me know in the comment section below. As always, I will add the link to this project in the description for you to check out, and I will see you in the next video. Till then, happy coding. Bye bye.